Hello everyone. Welcome back to my YouTube channel. This is Rishi and this is part 5 of the topic matrices. And in this video, we will be wrapping up the entire chapter, and in the next one, I will be showing you few example questions on how to tackle when it comes to matrix. Without any further ado, let's jump right in. In the previous video, I have talked about identity matrix, and it's a crucial concept if you would like to understand the inverse matrix. So if you have not watched that video, or if you do not have any idea on what is identity matrix, I would highly advise you to take a look at it first before coming into this video. There are a few checkpoints we have to understand throughout the inverse matrix part. The first one is we have to understand what is inverse matrix. You would have seen in your textbooks, you would have this equation which is AB equals to BA equals to I, where B equals to inverse of A. So if you're wondering, this -1 refers to the inverse of A. To understand inverse, let's take something much simpler. Let's go with fraction. Let's say 1/2. What is the inverse of fraction of this particular fraction? We call it reciprocal. I hope you all remember. Reciprocal is where you put 1 at the top and put the entire number at the bottom. So in this case, the reciprocal of 1/2 will be 2. So reciprocal and inverse are synonymous. So let's see, 1/2 multiplied by its inverse, which is its reciprocal. In this case, it's 2. When you multiply these two numbers, cut, you'll get the answer of 1. And this is essentially the same concept for inverse matrix. A, let's see any matrix, and then when you multiply it by its inverse, what happens is you get back the 1, which is identity matrix of that particular format of matrix. Or it works both ways, A times B and as well as B times A. To give you an example, I have this. Let's say this is matrix A and this is its inverse, A -1. Or also for the case of this equation, let's say it's also B. Alright, that doesn't matter. And if we multiply both of this, what do we get? Let me show it to you. For those who have no idea how to do the multiplication, trust me, you are way advanced in this video. You have to backtrack a bit and understand the basics first before moving on to these parts. So for those who have already watched those videos or have an understanding of how to do the multiplication, let's continue. 4172, multiply this with 2, -1, -7, 4. Fast forward, we have 4 times 2, 8. 1 times -7 is -7, so we will get 1. Then 7 times 2 is 14. 14 minus 14, we get 0. And -1 times 4 is -4. 1 times 4 is 4. When you add them both together, you get 0. And lastly, 4 times 2 is 8. 7 times -1 is -7. 8 minus 7, you get 1. For those who are familiar with the identity matrix, you would recognize this 1001 as being the identity matrix for the matrix arrangement 2 times 2. So just like how when you multiply a number by its reciprocal, you get the number 1. The same concept applies to matrix. If you multiply a matrix by its inverse, you will get the identity matrix for that particular matrix arrangement. It's actually as simple as that. So you might ask me, okay, Rishi, I understand what is inverse matrix. It's just when you multiply a matrix by its inverse, you get the identity matrix. Now, how do I find it? How do I get the inverse matrix of a given matrix? To identify the inverse matrix, it's pretty straightforward. We are given an equation which we have to use, and that will be checkpoint 2. And don't worry about the reasoning on how to derive this. You are not required to derive this equation. All you have to do is memorize it and implement it during the examination. So the equation goes something like this. Given matrix A is A, B, C, and D, its inverse will always be 1 over A times D minus B times C, multiplied by a rearrangement of the given matrix. A and D switch places, and both C and B become the negative form of themselves. So if they are initially -3, they become 3. And if they are initially 2, +2, they become -2. Just flip the signs. And this is how you derive the inverse for any given matrix. By the way, for Form 5, you are limited to find the inverse matrix of 2 times 2 matrix arrangement only. So don't worry about finding for 3 times 3 or 4 times 4. It's just 2 times 2. Let me show you one example. Let's say A is 7, 2, 3, 8. Using the given equation, let me use something like that. Let's use dark purple. Let's say A inverse. It's going to be 1 over, in this instant, A is A, B, C, D. In this instance, A is 7 multiplied by 8 minus BC will be 2 times 3. 2 times 3. And then we have the matrix here. D is 8. Then we have negative B. So 2 becomes -2. 3 becomes -3. And 7 comes around here. Alright, there we go. And then if you were to solve this, we have 1 at the top. On the left we have 56. On the right we have 6 times 8, -2, -3, and 7. So we will have 1 over 50 multiplied by 8, -3, -2, and 7. So if you would expand it, you would get an answer of 4 over 25 negative 1 over 25 negative 3 over 50 and 7 over 50. And this will be the inverse matrix of A, 7, 2, 3, 8. The inverse will be 4 over 25, -1 over 25, -3 over 50, and finally 7 over 50. this is how you find the inverse matrix for any given 2 times 2 matrix arrangement. You might think that this is the end of the video, but hold up. We have one last checkpoint. This is determinant. If you remember, the equation above used a particular fraction, AD minus BC. And we know that for a real number, the bottom part, this part, cannot be equivalent to 0. You can't have 0. Because if it was 0, you would have 1 over 0, which at form 5 level, we do not consider this as a real number. Well, at any level, it's not considered a real number. But at form 5 level, we consider it as undefined. Or if you put it in your calculator, you will get, in capital letters, all caps lock, maths error. So, following this principle, we know for a fact that AD minus BC cannot be 0. AD minus BC cannot be and must not be 0. If at all, the given matrix that they, for example, they give A as 7, D as 2, then they have 1 here and 14 here. So since this is A, B, C, and D, we know that the determinant for this particular matrix will be 1 over 7 times 2 minus 1 times 14, which will give us 1 over 14 minus 14 and giving us 1 over 0. 1 over 0, as the principle says, it's undefined. Therefore, it's safe to say that this particular matrix, which is 7, 1, 14, 2, does not have an inverse form. This does not have an inverse form. That's it. So these are the 3 main principles that you have to understand in inverse matrix. Let me give a recap. Number 1, we learned that AB, which is A inverse. So A multiplied by A multiplied by its inverse, or its inverse multiplied by A, we will get the identity matrix back. The second checkpoint, we learned how to find the inverse version of any given 2 times 2 matrix arrangement. And in the final checkpoint, we learned about the determinant. And with that, we have come to the end of today's video. And I hope you learned something. And stay tuned for the next one. In the next video, I will be discussing few exam questions on matrix and how to solve them. Till I meet you in the next one. Thanks for watching. Bye-bye.